Okay, so our question is how many molecules are in a 30 milligram tablet of this. And what is this that we're looking at? Well, this is actually pseudoephedrine hydrochloride, which is the active ingredient in some types of Sudafed. And I say some types because not all Sudafed contains pseudoephedrine hydrochloride anymore. There is now an alternative to that. I will say from my standpoint and from my background with nursing and the things that I've seen, pseudoephedrine hydrochloride is what you want if someone needs to use Sudafed. This is the better of the two. The reason that there's an alternative to it now is because this pseudoephedrine hydrochloride can be broken down, and people make meth out of it. And how do they make meth out of it? Well, that's a different video, and really I don't know, actually. I'd have to look into that. But I do know that people break it down and make meth into it, and that's why you have to sign for it. It's over the counter, but you have to give them your driver's license and your signature in most states, at least. I think the further south you get, there are some states yet that don't require that. So that's just some history on pseudoephedrine hydrochloride. It has nothing to do with the actual problem here, but it's interesting. Okay, so the question is how many molecules are in a 30 milligram tablet? Well, the first thing that we need to talk about, unfortunately, is the idea of a mole. And let's talk about this. Okay, so let's get a color here. Oh, that's why. Okay. I think we should be set now. Okay, so 1 mole. The best way I can explain this is 1 mole is a direct translation between grams and atomic mass units of an atom. So 1 mole equals the number of grams, which is equal to the number of atomic mass units. So let's do an example. Okay, if we look at let's just pick one. Let's pick chlorine. Okay, so if you have your periodic table, take it out and take a look at it, and you'll see that it has an atomic mass of 35.5. So we're going to say 36 atomic mass units, which would be equal to 36 grams. So 1 mole of, and I should specify here what we're talking about, 1 mole of chlorine equals 36 grams, or 36 atomic mass units. But that's not it. It gets more complicated than that, unfortunately, because what's a mole? Well, like I said, a mole is just a number. It's a direct translation, like I said, between grams and atomic mass units. But a mole is actually a number. So, and that number is Avogadro's number, and maybe you've heard of that. So 6.022 times 10 to the 23rd power, and this is atoms. Okay, this is the number of atoms. Okay, so this many atoms, okay, equals the number of atomic mass units, which is equal to the number of grams. And I probably didn't make sense to you. And you might get through this whole video and it won't make sense to you. And I encourage you to keep trying and keep practicing problems, because it takes a lot of students a long time to grasp the concept of a mole, including myself. It took me a long time to figure this out too. One thing I want to point out is a mole is not a molecule. Okay, I tutor a lot of first-year chem students that tend to think a mole must be short for a molecule, and that's not the case. So don't get confused with that. Okay, so a mole is a number. So this is our number. That's a mole. 6.022 times 10 to the 23 atoms of chlorine equals 36 grams, or 36 atomic mass units. How confusing, right? Well, it's okay. If you don't understand it right now, that's okay. We can still do the problem, I promise. And like I said, it's one of those things that just takes practice, but the more we do, the more you'll understand. So, our question is how many molecules are in a 30 milligram tablet? Well, the first thing we need to know is we need to know the molecular weight of pseudoephedrine hydrochloride. And the way we do that is we go through each atom, and we look at the atomic mass, and we multiply it by the number of atoms we have. So let's go through and do this. So we have carbon. We have 10 atoms. We have an atomic mass of 12. So that should give us 120. Okay, hydrogen, we have 16 atoms with an atomic mass of 1. So that gives us 16. Chlorine, we have 1 atom with an atomic mass of 36. So that gives us 36. We get to nitrogen. We just have 1 atom with an atomic mass unit of, let's see, 14. Okay, so we have 14. Then we go to oxygen. We have 1 atom of oxygen, atomic mass unit of 16. So we get 16. So if we add this up, let me just double check to make sure I didn't make any mistakes, because it's been known to happen. And 14 and 16. Okay, so we come up with about 202. And because I'm using an example, I'm going to use the number that the book has instead of what we came up with, because the book is a little more specific, and if we stick with that number, we can ensure that we get the correct answer. So the book came up with 201.7 grams. Okay, and this is grams per mole, remember. Okay, now if you're wondering why we came up with 202 and the book came up with 201.7, is because, for example, if you look at hydrogen, it has an atomic mass of 1.01 technically. And it could actually be even more specific than that, I'm not sure. The table I have it kind of falls right in the middle of periodic tables that are out there. So there may be some that are more specific. Truly, I'm not sure if there is, but there could be. So hydrogen has an atomic mass of 1.01. We use just 1 because we're rounding off here. So if we did that with each one, this is the exact number we would come up with. Well, that's not the exact number, that's the rounded number. But we'd come up with 201.7 grams per mole. Okay, so let's do this. We know that 1 mole is equal to 201.7 grams. Okay. Now, let's get back to this. Okay, if we looked at a mole of an atom, it's equal to that atom's mass, which is equal to the same number in grams. Okay, we can do the same thing, not with an atom, but with a molecule. So if we took this whole thing, okay, and we looked at 1 mole of that, it would be 201.7 grams, because that's the number we came out with, right? So 1 mole is 201.7 grams. Okay, now, our question is, how many molecules are in a 30 milligram tablet? Well, if we take 30 milligrams, we need to get to grams, right? So we can move our decimal over 3 places to get to grams. So we end up with, and if you're in nursing, always remember to put a 0 in front of your number. It is actually very important. 0.0 doesn't affect your calculation, but if you're ever charting things, it's important to put that in front. Okay, 0.03 grams is what we come up with, right? So let me change my color back. I think this is the color I had. We have 0. Nope, that's not the color. Let's keep the same color. There's the color. Okay, so 0.03 grams, because that's how many grams or milligrams of this molecule we want, right? Because we know that this many grams equals 1 mole. So this many grams equals how many moles? Well, let's calculate that out. So we have 0.03 times 1, of course, same number, divided by 201.7 grams, equals, okay, so we could write this out, and maybe, I guess I will. Okay, so 0.000148736 is what we come up with. And remember, this is in moles. Okay, so this many moles equals this many grams. Well, what does that tell us? That tells us how many moles. But our question is not how many moles, although molecules and moles look similar in their spelling. But like I said, remember, mole is not a molecule, so don't get confused. How many molecules are in a 30 milligram tablet? Okay, so we have it down to moles right now, but we want to know how many molecules that is. Well, how many atoms are in a mole? This number, right? We have 6.022 times 10 to the 23rd power atoms are in 1 mole. So if we take this many moles times that number, so let's take our number times 6.022 times 10 to the 23rd power, we end up with, and I'm going to round off here, but we end up with 8.9, let's go 8.96 times 10 to the 19th power molecules. Okay, now if you're getting confused with because I think the way I explained this was kind of confusing, between the atoms, because remember I said atoms, this is how many atoms we have per mole, and then I said this is how many moles, but it's asking how many molecules. Well, we're doing this is the number of atoms, and we're using this number, but we don't say it's in atoms because this is not an atom. This is a molecule, right? And that's what it's asking. How many molecules are in a 30 milligram tablet? So that's I'm trying to think of a better way to explain that. I don't know how to explain that any better. So hopefully that makes sense. But 8.96 times 10 to the 19th power in molecules. That's how many molecules. So that answers our question. So, like I said, if you didn't understand it this time, that's okay. Keep doing it, keep practicing it, and it will make sense.